In this lecture, we'll discuss some tips for debugging programs that involve different types of loops. Let's say we try to debug our program or try to fix some runtime errors. It's usually a bad idea to apply patches to our code. So what's a patch? It's basically a piece of code that we write on top of an existing piece of code that's supposed to fix some bug in the original code. I'm sure you've heard of the term patch before in like games and other software where you update your program to patch 2.3.9 or something like that. And these are just little pieces of code that we write on top of existing code. Sometimes this is just to provide updates, or in this case, we're just trying to fix some bug. For example, let's say we have some data in a file, and let's suppose it's formatted like this: numbers 1 through 12. The first 4 numbers are on the first line, the next 4 numbers are on the second line, and the last 4 numbers are on the third line. And the goal here is we want to get the sum of every single line. So here's the code that will take care of this. So it will print the sum of all the lines. So we have a for loop where we take a look at each line, and then inside the body of the loop, we'll take care of looking at each number in that line, and then we just read it in, and then we print it out, and then we take the sum of it. So yeah, this will read the numbers, and it will print the sum of all of them. But my claim here is that we're going to get what's called the no such element exception. Because what's going to happen is we're going to read a non-existent fourth line. We're going to read a value that's not existent in our file. So we're going to try to read more numbers than we really have. So take a minute to see if you can figure out what is actually causing this issue. If you need to, go ahead and pause the video and start it back up when you think you have the answer. Okay, the problem is our condition right here, because the outer loop here is trying to read each line, and we're saying that I is going from 1 to 4. This means that we're trying to read 4 lines of numbers when we only have 3 lines. So let's try fixing this by applying a patch. So here's one way we can modify our program. So inside the body of the first loop, I now have an if statement here that says if I is not 4, then let's run the code as normal. But if it does become 4, we just want to skip it. Now this does fix the problem, but it's not really the best solution. It shows that the programmer doesn't know why the problem happened. It just knows that there's an issue with getting a 4 and we need to fix that. So yeah, I mean, using an if statement like this is not the best way to fix this. This type of error that we're encountering is actually an example of the off by 1 problem. And this is a very common problem in our programs. So the off by 1 problem is that our loop either executes 1 too many times or 1 too few times. So here is the corrected version. So it does address the issue, because now instead of checking if I is less than or equal to 4, it's checking if I is less than or equal to 3. Now you could also just say I is strictly less than 4. Either one of those would be fine, but this fixes the problem and it shows that the programmer understands what was causing the issue and how to fix it. So this is a much better way of addressing the problem than trying to apply some kind of extra code to fix a special case. Because otherwise you could have some additional bugs, and if you keep trying to throw patches on top of patches on top of patches and have this whole kind of patchception going on here, then your code's going to get really messy. So it's best to just understand what is actually causing it, where the offending line is, and fix that problem. Here are some tips for debugging loops. The first thing I recommend is to hand trace your code. Now you might think that this is pretty annoying because you're having to do a lot of handwriting, but it is worthwhile. What I suggest is for each iteration, just keep track of what each variable is. So just keep track of the values. That way you can actually see if they're matching what you intended them to be. Now sometimes your IDE will have what's called a debugger. And what this does is you can take a look at your code one line at a time and just monitor what the value is of each variable. So you can run one line of code, see the values of your variables, and then move on to the next line. And so instead of running the entire program from start to finish, you can just kind of pause after each line and just see what your program is saying. Maybe there's a value that's completely different than what you expected. Now, Dr. Java does have a limited debugger, but it does have one. But other IDEs such as NetBeans and Eclipse have much better debuggers. The next step is to check for off by one errors. I mean, as we saw in the previous example, it's very common to run too many iterations or too few iterations. So just make sure that your loop is running the correct number of iterations. The next thing I suggest is if you get an infinite loop, check your condition and update statements, because you may be using the wrong inequality operator, you may be using the wrong relational operator. A lot of times what will happen is maybe you're checking to see if a value is less than something else, but your update statement is decreasing the value, or maybe you're doing the vice versa. So just make sure that you're updating your loop control variable correctly, and you make sure that your condition is checking the correct things. Finally, when you run your program, print the value of each variable after each iteration. So what I'm saying is include some print statements and just run your code and see what gets printed. I use this a lot when I'm debugging loops just to make sure that I'm producing the right output. Or if I'm getting stuck somewhere, I can actually see where in my code I'm getting stuck.